Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials or any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com. Thank you.
Yes. So now let us say one should be group by what? Group by, we can use what? This is the input. Yes. Yeah. So let this be input here. Yeah. We can use what? One of them as what? Group by. Yeah. Or else one of them, whichever you are comfortable. Just start using it. Yeah? So then, yeah. Once we do that calculation, we can also what? Perform calculation. Go to calculate and apply whatever calculation that you want. Yeah? Let us say max of salary or whatever you want. Yeah? Max of salary. Right? See whether it will be validated or not. Can you see aggregate functions are allowed in aggregate transformation? So we cannot allow. Right? So let us use what? Only sal column. Yeah? So I'll just delete this. Use sal column only. Clear, no? So that's it. Yeah. So this is what we need to do. Like how one can start performing what? Group by department, and salary is for calculation for rank. Yeah. So please select this. I repeat, group by is what? Department number. So within each department, so whoever is drawing more salary, right, you'll get ranks. Yeah. So please select this. So department number is a group by enabled, and salary is what? For calculation. That's it. Yeah. Well, perfect. Four is done perfectly. So you also have to do it, madam. Yeah. We just have to reverse this. Yeah. This should be, we need to select one of them as what? Group by column. Yeah. Correct, no? Yeah. You can try doing it, Priyanka. You'll get it.
My
Dinesh?
system is slow,
Yes.
that's why I'm not able to.
Yes, yes. But anyway, take your time, madam. Yeah, now Dinesh, select the department number as group by. That's all, Dinesh. Yeah. So yours is done. Dinesh part is done. And even, yes, there is also done. Perfectly done. Yes. And then, so mine is also done. Yeah. Now, let us go to properties. That's what we need to understand. Can you see here? This ranks could be from top or bottom. You can see drop down, right? Top or bottom. Let us say top. How many ranks that you want? By default, you'll have one. So we can define here. So based on how many you want. Let's say I want three ranks. Let us say in each department, if we have, let us say, uh, three or four, right? So you'll get top three ranks only. We can see, not others. Remember, yeah.
Can you please select that department number and whatever we have to select? I'm not able to do that.
Yeah, can you see, madam? Go to ports. So this department number,
No,
we need to
no,
enable
I'm
this as
not
a
able to
group
do.
by.
My system is stuck. My system is stuck.
Okay,
That's why I'm
one
not
sec.
able to do.
Yeah, one sec, madam. Yeah. For yours is salary is there. Yeah. Okay. Just a minute. Yeah, first let us go to department number and salary. Yeah, go to ports, tab, and yeah. Now, can you see here? This is what we need to enable. Yeah.
Yeah. Okay.
So that's it. So once we do that, say okay. Yeah. So make sure that you enable this particular rank port. R, right? R indicates what rank. So rank calculation happens based on what? Salary column. But group by is what? Department number. That's it. R indicates what? Rank port. That's what we need to do. Yeah. I repeat, R indicates what? This should be enabled. Yeah, Delhi. And Dinesh, yours also R should be enabled. Yeah, this is perfectly done. He has done it perfectly. Yeah. So that's it. Say okay. Yeah. All done perfectly. Now say okay. Yeah. Now go to target, add target here. Yeah. Yeah. That's it. Now select, let us say, in this department number for a given salary, what are the ranks? Yeah. Select what? Rank and connect it. That's it. Now let us save it and build workflow and see whether we could able to get the expected ranks in the target or not. Yeah. Probably we'll do that after the break. Can you take a break for some time if you're okay? Yeah. Yeah, fine. Anyway, let us build a workflow. After that, we'll take a break. Go to workflows and create a workflow. Yeah. Let us finish this. Workflow underscore what? This particular rank. Fine. Now create a task. Go to task and session rank. Session underscore rank. Yeah. So where is this mapping rank you need to select? Yeah, this one, right? Mapping rank. Say okay and done. Yeah. Now connect tasks. Yeah. That's it. Yeah. So yeah, we need to we have not changed this target, all right. Okay. Connection is there. Only target we need to change. So C colon slash target. Yeah. Now you can supply here output file name, which is scratch underscore rank dot txt. That's it. Yeah. And then save it. Yeah. Yeah. This part anyway we all know. Yes, this is doing. Oh, mapping rank some configuration problem. Delay. So we need to make it valid. Go to designer and fix that problem, Dinesh. Sorry, Delhi. Let us see what is that problem. Yeah, mapping is invalid. Can you see here, Delhi? It's invalid, right? We can see invalid symbol reference. Looks like, yeah. So which means you have not mapped this column, salary column to what rank. That is what it's saying. Invalid symbol reference. Can you see here, Delhi? Yeah. Now it is mapped. So other thing, extra thing. So let me try deleting this, and then sorry, yeah, and then say, yeah, now let's map it. Yeah. Now let's go over here, go to ports. Yeah, can you see here? Rank port. Sorry, yeah, what I'm doing. This is a rank. This is a group by. That's it. Right? Apply. Say okay. Oh, department number is gone. What happened? It should be input is should be enabled. Yeah. A rank is fine. This should be fine. Yeah, let us take department number. Connect to this. Yeah, that's all. Now let us save it. Can you see here? Mapping is valid. Yeah, Delhi. Now you can just go to workflow manager. Yeah, I saved it. Yeah. Now you can see, right, why you got error. If you don't map any column which it expects, right, you'll get invalid symbol reference. That's what we could see, right? So after this, you can just run this particular workflow. Start the workflow. Yeah. So now let us look at the result here. What is this rank, right? Yes, successful. Yeah. Now we can go and see the result here, which is a rank 1, right? It's in the bottom. Yeah, we can see, right, under department number 10 there are 3 employees. Yeah, based on maximum salary, right? See 5,000 first rank, 2450 second rank, and 1300 third rank. Similarly, under department number 20 we can see if the if the same salary, right, 3,000 right, same rank will be assigned. Yeah, and then department number 20 same, there is one more employee who is drawing what less salary, so that's where you can see rank 3. Similar on the department number 30 we can see 1 2 3. This is how rank calculation would take place. This is a common thing, right, everywhere. Yeah, same thing it also does it. You got, right? So any questions from anybody? I think everybody has got the same result. Perfectly done, except Priyanka. What happened? You're still doing, right?
No, I have done. I'm just
Perfect.
trying out some
So
things.
okay then.
Yeah.
Okay, fine. So that's about rank transformation. With this, probably we'll take a break. So we'll come back at around 3:40, 3:45. Yeah. So then we'll continue from here. Fine, no? Yes, Dilip. Yes, Dinesh.
Partitions is possible by using that.
Your voice is not clear, Dinesh. You need to come closer to the mic and
Yeah,
speak up.
the partitions is it possible? Partitions.
Yeah, I'll talk about that because there's a concept called parallelism. Within the
Okay.
parallelism, is one of the parallelism technique is what partitioning parallelism. Yeah? That I'm going to talk. Like pipelining
Sure.
and partitioning. We've got 2 types of parallelism techniques. That anyway I'm going to talk. And that is part of actually optimization. That topic anyway I'm going to cover tomorrow. So morning I'm going to talk about theory about that. Huh?
Yeah.
Fine, right?
Yeah.
Then we'll talk about how to configure. It's very simple. We'll do that. Yeah. Fine. Okay then. Yeah. So remember, in data warehousing context, or especially Informatica context, why we use Informatica? To perform integration. For what? Large volume of data. Remember, yeah. So for what? Large volume of data. Correct, no? Now, the large volume means what? Data will be in terms of millions, billions, trillions, jota or zettabyte of data, right? So because when you try to process geographical data or any image data, even financial data, it will be very large in size. Yes or no? Yeah. Now, to process that, there are two ways to process this particular data. One, we can use what traditional way, or we can also call it as what sequential approach. Second is what parallel approach. Remember this, yeah. Now the question here: how are we going to start what I call performing sequential processing and see the problem that we have within this sequential approach and see how one can overcome that particular problem by using what parallel processing, right? For example, let us say we have got 1,000 rows data. Yeah? So rows is what row count is let's say 1,000. Now the next is what time window is what so time window is, let us say, 1 minute example, or let's say 10 minutes. Yeah, fine. Now, so yeah, now what, how this particular row processing would take place is 1,000 rows processing, right? Let us say you have got ETL job like this, E, T, and L. Yeah, so this is a job. Yeah. Now, how this particular job processing would take place? So, what it does, E, sorry, E, the result of E will be sent to what? To a disk. I repeat, result of this particular E will be sent to what? A disk. Yeah. Then what happens? Then from disk, it is going to read the data by whom? T. So T is going to get the data from disk, yeah, and start reading it. Once it is done again, this guy is going to dump data to a disk, and then followed by load, which is L, is going to pick up the data from where? Disk. This is what happens actually in case of traditional approach. Yeah. So then with this, what is the problem here? There is a lot of usage with respect to what? Disk. That is the one thing. The problem is what? IO overhead, or we can say disk overhead. Fine. Yes or no? Now, which means what? We are performing to and fro by using what? Disk as a intermediate storage media. Right. Now, how next problem is what? We are doing it sequential. In the sense, sequential means what? One after another. Correct, right? So um, meaning, let us say after successful completion of this particular E, then it will be dumped to disk. After that only T will be started. Remember this, which means what? E, T, and L execution of those would take place in a sequential way. Remember, no? So there is a problem. These are the two problems. With this, what happens? Though we have a resources, you know, I repeat, though we have got resources like we have what you call memory, disk, processors, all. We are not utilizing it. If you go with this approach, right, we are not utilizing all the resources effectively. Yeah? Now the question: how are we going to start making use of these resources? That is going to be the question mark. Yeah. So to answer that, we have got what we call parallel processing. That's the entry point. And that to, let's say, 10,000 rows you could able to process, let's say, 10 minutes. Now what will happen if we get 1 lakh rows, yeah, or 100,000 records? Then what will happen? It will take how much? So 1,000 into, let us say, 100 times. Yeah? So it will take what? 100 times to process it. So but the expectation is what? It should also be completed in what? 10 minutes, which is highly impossible. So that is where we have got the biggest problem with the sequential approach. Now the question, how are we going to solve this particular problem so that we can get it processed in short time? So that is where we need to go with what? Parallel approach. Yeah. So parallel meaning what? Simultaneous running of several tasks. For example, let's say we've got task 1, task 2, task 3. In this previous example, task 1 is, let's say, E, and task 2 is what? T, task 3 is what? L, right? Now, so we need to make sure that all the tasks like T1, T2, and T3 should be executed in parallel. So there should not be wait, remember. So how to take care of it? So that is where we use what? Parallel processing. Now the question, how this particular parallel processing is going to work? Yeah. So what are the different types of parallel processing techniques that we have within this particular Informatica? Or we can say type of parallelisms that would be supported by Informatica. So this guy supports what? Two types of parallelism techniques. I repeat, this particular Informatica supports two types of parallelism techniques. One is going to be the pipeline parallelism, and second is going to be the partitioning parallelism. Remember, yeah, these are the two parallelism techniques supported by what? Informatica. Now let us talk about how they are going to work in order to what? Make the things happen faster than expected, right? Now pipeline, to understand this pipeline concept, I think pipe definition I have already given. So pipe, just to recap, pipe will have what? Two ends, one writer end, other reader end. In between, you'll have what you call pipe. That's it. Yeah? So that's what the simple way to understand. Or we can say that stream of data. Like for example, if you take hydraulic systems where the stream of fluid, a stream of gas, a stream of water, a stream of any liquid would take place, right? In that case, they will transfer or they will make the fluid to be flown from one end to other end based on what? A pipe. Pipe is a stream, or pipe is a media through which we can transfer the water or any liquid from one to another. In our warehousing context, we transfer what? Data instead of liquid. That's all the difference. Rest everything is same. No? Here you will have what? One writer end, other is what? Reader end. This is what is going to be the pipe. Yeah. So that's a definition of pipe. Pipe could be nameless, name pipe, all that doesn't matter. We don't need to worry about what type of pipe all about. It's just a pipe. That's it. Now pipe also can be replaced in the context of warehousing. One is going to be what you call buffer, and second it could be what you call memory, and third it could be what you call cache, and fourth it could be what you call disk, and fifth it could be what stage. So which means what? Pipe could be anything, but by default if you say pipe, we use what you call buffer. Remember this. Yeah. So in the context of Informatica, the name of this is going to be what? Dtm buffer. Like for example, we talked about in the morning, right? Dtm architecture, where we have Dtm process. Under that, we have got a number of threads like reader, writer, transformation, mapping thread, session thread, and pre-session, post-session, and any other threads. Yes, sorry. But how the flow would take place? How do you make multiple threads to talk to each other? By using what? Dtm buffer size. Yeah, we define this. By default, you will have some size, 128 MB, whatever. But you can change that number based on the amount of data that we get it processed. Yeah, clear, right? So Dtm buffer, or we can also say that Dtm buffer size. We can set it. Yeah. So this is the one, right? Now, which is customizable, which is very much required, which is very much required to be modifiable, because in order to take care of your things happens faster. Let's say your job is running slower than expected. In that case, we just have to think of this as one of the tunable parameters. Yeah, fine. That's fine. Now, so how this parallelism would work here? Yeah, fine. Let us take 1000 rows of data, like what we discussed, right? So what will happen? You have a E, you have a T, you have a L, right? And here we define buffer size, right? So let's say buffer can hold 100 rows, which is what? Buff size, right? Then what happens? So as and when E completes 1000 rows, sorry, yes, 100 rows, it is going to place this 100 rows in what? Buffer, remember, which can be read by downstream transformation, which is going to be T. That's it. As and when this dumps or what you call flushes 100 rows to a buffer, right? This guy will start processing what? Next set of what? 100 rows, and next set of 100 rows, and so on. Which means what? Every time this guy also will be busy. First time here 100, so here you'll have what? Second chunk. Then by the time second set sends, right? In the sense second what you call buff data to this guy, so this guy will be under second, this guy will be next. In the sense what? At any given point in time, what this guy will be one level ahead, this guy will be one level behind, and this also will be same. Yeah, same concept here also. So if you understand two, same concept applicable for what rest of the downstream transformations. Remember this, which means what? With this approach, we are trying to make everyone busy. Meaning what? We are trying to make E and also T runs at the same time. That is what we call simultaneous running of several tasks. Remember this, which means what? In this way, we can make all the resources busy, in the sense with respect to memory, with respect to disk usage, with respect to what? Processors. Now, as a result, we could able to get what? More or better performance benefit. Remember this, yeah. This is a one way, yeah, to achieve parallelism. And second is what? Can we just handle very large data with this approach in a short time? Answer is no, right? This is good till we process millions of records. But what if you want to process billions of records or trillions of records or much more than that? In that case, can we get it done in a short time? Answer is no. If yes, how it can be done? So that is where we can solve this particular problem by using what? Partitioning. Remember, which means what? Anything which can't be taken care by using pipelining parallelism, we can take care of it by using what? Partitioning parallelism technique. Remember. Now, what is meant by partition? Definition, you need to understand, right? Partitioning means what? Divisioning. It's as simple as that. Yeah, I repeat, divisioning. So what to divide here? Divisioning of data. Divisioning of what? Data. For example, let us take same example. Let us we have got 30,000 rows. Yeah. Now, so let us say if we go with a simple pipelining, it takes what 3 minutes to complete. Let us take that. Now if you get, let us say 3000 into 10, so 30,000 into 10, can you get it processed in 3 minutes? Answer is no, which is not possible, right? 3 minutes is not possible. So how do you get it done? That is where the question mark comes in. So which can be accomplished by using what?
To get our channel membership, click onto the join button, select the 3D99 plan and grow your skills immensely.
By adding 3 partitions over here, 3 or 4 partitions. That's all. Simple answer to that particular question. 3 or 4 partitions. Yeah. So that's it. Like how one can start what I call solving this particular problem. Let's say there are 30,000 rows which need to be done. Let's say 3 minutes. If we could do it by using a prior planning. Same thing. Let's say into 10, which is let's say this in 10 times data, right? We need to do it in what 3 minutes. Can you do it with a prior planning? Answer is no. So how do you do it? That is where we can introduce what partitioning. So what we need to do here, partitioning we can also replace with a term which is what we call node. So I repeat, we can also replace partitioning with what? Node. Or we can say that partitioning concept would be accomplished by using what? Nodes. Nodes means basically logical nodes. Remember, not necessary to be physical nodes. So meaning what? If we have one physical box, for example, let us say PB1 has got what do you call 32 CPU box. Yeah? In that case, how many logical nodes we can have it here? Max we can go with what? 64, which is going to be the best practice, which means what? Logical node term has been derived from where? CPUs. Remember this. Yeah? I repeat, logical node within a same physical box has been derived from where? CPUs. So per CPU, we would have 2 cores normally, and each core we can have 1 node. This is going to be the best practice. But there is a provision to add more than 64 nodes. If we do that, we are not going to get the benefit. Instead, we are going to get what? Degradation. So that is where we should go with what? Best optimal way, so that we could able to avail all the resources in more effective way rather than what you call getting into degradation part, right? So that's it. Now the next question, that's about partitioning, right? Next question is what are the different ways of partitioning so that we can divide the data? So ways of what partitioning. So that is going to be the next question. So in order to answer this, what need to be done here? So first of all, let us say we need to understand the data. So after carrying out analysis with respect to source system data, the next step is what? We need to start getting into what kind of partitioning technique that we can adapt so that we can start performing what? Divisioning in a short time. For example, let's say we are going to get key-based data from the source. For example, we have got different tiers of customers or different types of customers, like a tier 1 customer data, tier 2 customer data, tier 3 customer data, and so on. Now the question, how are we going to start making use of this particular partitioning technique, or what type of partitioning technique that we can use so that we can start what we call performing a divisioning? That is where we have got what different types of partitioning techniques. Broadly speaking, we have got a key based partitioning techniques, and second is what key less partitioning technique. As the name suggests, key based means what? We are going to make use of key, which is going to be the primary key or foreign key or composite key or any other key. Ultimately, we are going to perform the divisioning based on the key. But in the context of partitioning, we call this as what? Hash key. Remember this. Yeah? I repeat, key based means what? Normally, this any warehousing tool uses what I call the hash based approach in order to perform what I call divisioning. Remember this. Yeah. So that is a starting point. Now I'll extend this on tomorrow's session morning, because this time extending this is not a good thing because there's a lot of depth in it. I'll expand this on tomorrow's morning session, like what are the different key based partitioning techniques we have, and what are the different keyless partitioning techniques we have, and which partitioning techniques should be used where and why, and business scenarios. That part I'm going to talk about that in detail on tomorrow's morning session. Fine. Now, because at this time I think people might feel sleepy if we talk about too much theory. That is why I'm trying to stop here. If you're okay, I don't have any problem to continue this. I'm okay for anything. Fine. You're all there, right?
Yeah. You can continue, I think.
You can continue, huh? Fine. So if you are okay, I'm okay. Yeah. So fine then. So let's continue. Yeah. So now let us talk about this particular key based. So now the question is what if you go with a hash partitioning technique, which is first and foremost key based partitioning technique. So I talked about one of the business case, right? Like we have got, let us say, tier 1 customers, and let us say tier 2 customers, yeah, and we have, let us say, tier 3 customers, right? So now what need to be done here? Tier 3 customers. So all of them would be categorized under, let us say, customer type, right? So customer type, right? So which means what? Now the question, within each tier customers, here let's say there are 100 records. Here let's say there are 10 records, and let's say here let us say there are 1000 records. Example, right? Let us take this. Yeah. Now what will happen if you now we need to start performing what? Key based. Why? The way we apply are the kind of rules that we apply for what you call tier 1 customers, which are different from tier 2 and tier 3. So which means what? We should make sure that we don't lose any business functionality. To do that, what need to be done here? Based on customer type, which means based on customer type, let's say tier 1, first customer type, these records should be sent to what? Node 1, which is going to be what I call partition 1. Remember this. I repeat, all the tier 1 customers data should be sent to what? Node 1. So in context of Informatica, we can also use a term which is what I call partition 1. Now, how many records we have it as part of partition 1? So we have got 100 records. That's it. So that is going to be the first thing. Similarly, same thing need to be done for what other tiers. Let's say tier 2, where you will have what I call node 2, corresponding node should be read as a node 2, and partition will be what? Partition 2, and number of rows will be what? 10 rows here, right? And similarly, third tier comes into picture, right? So now, yeah, let us take this. Yeah? So tier 3 data, right? Tier 3. So node 3, and then we have got partition 3. Here we have got 1000 rows. Fine. Now let us say we have got this kind of what I call input data. Yeah. Now, if you partition based on what customer type, so they have been sent to what? Appropriate nodes. And within each node, what we do here, within each node here, we apply what? Some logic. Logic, let us say, we apply aggregation here. Aggregation based on this customer type. That could be any type of aggregation. Let us say standard deviation, right? Let's say we perform standard deviation based on this tier 1 customers. If the customer type is a tier 1, then we apply what? Aggregation. And if a customer type is what tier 2, we apply, let's say, variance. Yeah. And if the customer type is what tier 3, we apply, let us say, average. Yeah. Fine. So which means what? Depending upon the type of customer, one can start performing, let us say, appropriate aggregation. Remember, or it could be same also. It's not mandated that for every type of customer we need to apply different type of aggregation. It could be same or it could be different. The reason why I'm saying different types of aggregations here. Why? Because this is a worst case scenario where, let us say, the type of logic that we use for tier 1 customers, which is different from what tier 2 and tier 3 customer. That's what I meant to say here. Yeah, that's a major part of this particular story. Yeah, so that is where we should never ever send all the records to one partition and apply what? Common logic. You got the effect of this, right? So we divide the data, and and send you appropriate nodes, and each node will apply appropriate aggregation. Remember this. Yeah, that's one thing. Now let us take another way. Let us say some records. Yeah, assuming that worst case scenario. Let me take same thing. I'll just copy and paste here. Yeah, copy and paste here. And let us say aggregation is same everywhere, which is going to be what? Standard deviation, and so on. Yeah. Let us take that also. Best case. Yeah. This I'm talking about what? Best case scenario. Yeah. So let us take this. Yeah. So in this case also, what happens? So what do we need to do? Divisioning part in this case? Still yes. Why? Because after this aggregation, right, there could be some other logic which could be based on what? Type specific. Remember this. In this case, it could be same, but some other logical cases or rules where it could be different. You got right? Remember that. That's a one more case. And next is what? Let us say if you try to spread in the sense, let's say tier one data in let us say some records out of what 100 records, 50 records in one node, and rest of the 50 records in what? Another node. Let's say this is going to be node 1, this is going to be node 2. Clear, no? Yes or no? In this case, what happens? It is very difficult to perform any logic part. Yeah, and that's one thing. And second, let's say though we could able to perform, we don't get what much benefit with respect to performance, because we are trying to make multiple nodes to talk to each other. Across will have overhead, within itself will not have overhead. Remember this. Yeah. So we should always think of to a maximum extent, try to use what? Within itself, so that you'll get better performance results. That is why while configuring the partitions or corresponding nodes, we should be very careful. Based on the logic, we need to start what you call configuration of partitions. You got, no? So within always a best option. In worst case, only we can go with what? Across. Yeah, if it is really required to make use of more than one node to process your data belongs to each hash key. Remember this. Yeah, clear, right? So likewise, you can think of many examples where hash based partitioning will be used, or let us say key based partitioning will be used for. Like today we talked about some examples, right? Rank based on department, aggregation based on department, sort based on department. Likewise, you can think of many examples. Yeah? So let us say we need to start performing hash based partitioning for country code specific. The way we apply rules for India country, like legal bindings in India country is different from other countries. In that case, country code should be a key and apply corresponding rules. That is where we use what? Again, hash partitioning technique. Likewise, you can think of many examples where there is a need to think of using what I call hash based partitioning technique. Clear, no? That's a concept of hash based, right? Now how it works internally hash based, I don't need to explain, but I'll just add 1 or 2 points. Hash keys are just like what? Hashes with underlying what? Indexes, underlying what? VPs, which is what we call virtual pointers. As a result, this processing will be faster because at OS level it maintains what? Pointer level what we call traversal, and which in turn maintains what? Indexes. Index works based on binary pointers, which will have what? A faster processing. So that is why hash partitioning technique is one of the powerful partitioning technique, especially if you want to perform key based divisioning part, right? Now the question, if you have, let us say, worst case 1 million records in one, let us say one partition, and one record in other partition, and 10 records in other partition. In this case, what happens? So this guy will take much longer to process, and other two guys will process in short time. So how to what we call take care of this kind of issues? Worst case scenarios, let's say 1 million records, let's say tier 1 customers where, or tier 3 customers where we have got too many records, let's say 1 million, whereas tier 1 tier 2 we got very less number of records. So what will happen? These nodes, they'll process these records in a short time because the count is less, and this guy will keep on processing for a long time because it has got too many records. In that case, How do you take care of this particular problem? That is where we have got another partition technique, which is going to be the module based partitioning technique. Meaning what? This module based partitioning technique is going to work on top of what? Hash based. Meaning what? So let us, if we have too many rows, then we can still perform one, repartitioning, second, modules. Like in mathematics, we have got remainder operator, right? So we can use that in order to perform what we call subdivisioning. Yeah. So subdivisioning, we could do that, so that this the what do you call, the way or the kind of processing happens, this particular in let us say 1 million node data will be more or less equivalent with what? More or less equal, not equal, equal with what? Others. So which means our module value or remainder value, or let us say repartition value, should be proportionate or should be more or less equivalent with what? Other nodes where the data is going to get processed. So these things should be taken care by using what? Module based partitioning. Yeah. So this is one more. Now the next question, let us say there is a upper limit and there is a lower limit, or let's say upper bound and lower bound, or let's say range. Yeah. So there is a range of data defined here. For today's business, let's say we expect the data within the age range of, let us say, 20 and 50. In that case, how are we going to perform what divisioning part? Yeah. So that is where you can still make use of range-based partitioning technique, where we can define the range. So 20 to 40 should go to one partition, 40 to 50 should go to another partition, 50 to 65 should go to another partition, and so on. That's where we can define the range and start what we call performing range-based partitioning. Now the question, let us see if we deal with the database, especially DB2 or DB2 what we call related concept databases. Yeah, for example, DB2 has got its own built-in partitioning technique, which is what we call DB2 partitioning technique, which is very good actually, for especially for enterprise applications. In case if you want to make use of that kind of partitioning even for other databases, then we can still use that. Yeah, especially this has been designed for what? Databases, not for what? Other non-databases. Just remember this. Yeah, these are the different types of what we call key based partitioning techniques we have. On top of it, I would also add some more things like what is a grid, when to use a grid, and when to use dynamic partition, and how the partition would take place. Is it based on the nodes? Is it based on CPUs? Is it based on something else? So that part, well, I'll show it with a practical example rather than theory. What? Because if I extend too much, we'll get stuck here. Yeah? So now that's about, let us say, key-based partitioning technique. Now the question, is it mandatory that we need to perform this particular divisioning based on keys? Answer is no. For example, let us say we get the data based on what some 1,000 records. Yeah, so we don't care about the keys or whatever. As long as you could able to process this 1,000 rows of data within a minute, I'm happy. In the sense, customer is, let's say, happy. Yes or no? So in that case, how do you get it done? That's a question mark. We don't care whether the logic is same for all the rows, irrespective of customers, irrespective of product, irrespective of vendors, irrespective of patient masters. Yes or no? In that case, how do you get the job done? So that is going to be the next question. To answer that, we need to go with what? Keyless partitioning techniques, where we can prioritize what we call how well we can utilize the power of resources rather than what we call keys. So that is where we can use what? Keyless. And one of the keyless partitioning technique that we have within this data warehousing world or any other operating system is what? Round robin. Yeah? So we all know how this particular round robin scheduling algorithm is going to work within operating system, right? Same concept holds good even in data warehousing context. Yeah. Now let us try to understand how this particular round robin algorithm is going to work, right? So as the name suggests, round, meaning what? So it's going to repeat based on what? Time slice. Yeah. So time slice. So where there's a question of usage of time slice comes in. Remember, any OS works based on what? Time slice. For what? Task. Because if you have a task, it's going to assign what time slice of, let's say, couple of seconds, let's say 5 seconds, whatever. It we don't have control. There's a init we have. You can also call it as a scheduler, which takes care of it. So as and when, let's say we have got T1 task, T2 task, and also let's say T3 task. Let's say these are all what ETL example. Yeah. So now, as part of this, let's say particular divisioning, the first task will get, let's say, time slice of 5 seconds. Yeah. Whatever divisioning it can do within 5 seconds, right? It can do it. So out of 1,000 records, let's say it has done the divisioning of, let's say, 100 rows. That's over. Now, immediately, as and when this particular divisioning gets over, right? A task, this scheduler is going to hand over the task to what? Next one, which is going to be T2. Again, this guy might what you call perform with a similar time slicing. Within this, it could have been performed at 500 rows, because during that point in time, there could be what? Many resources which are free to use. Remember this, yeah? Which means what? Uneven distribution would take place in case of what? Round robin approach. I repeat, uneven distribution would take place in case of what? Round robin approach. So, but data processing will be faster. We don't care, right? Our logic is what? We don't care about how the order is going to be. As long as the data gets processed in a short time, it's fine. That is our requirement, right? To do that, we can use this kind of round robin algorithm, where it is going to work based on what? Time slice. That time slice you don't have control. That will be driven from operating system. Especially we call it as a init, or let us say simple scheduler. That's it. So we just start from a tool perspective. We just need to know how to select this particular round robin. That's all. Rest will be taken care by Informatica. It knows like how to talk to OS, how to get the job done. That's it. Yeah. So that's it about one of the what I call keyless partitioning technique. Yeah. So likewise, we also have got same partitioning. For example, let us same in the sense, same meaning what? Let's we have got T1 and T2 and T3. So remember, it's not mandatory that all the tasks should make use of similar partitioning technique. For example, if you take a hash here, same hash need not have been used over here. It could be even what this could be based on what? Some other, let's say module based, or other could be based on what? Some other, which could be based on what? Something else, which is let's say range or whatever. Yes or no? So it's not mandatory that all the tasks should make use of similar partitioning technique. In case, let us say T3 would require what? Range based divisioning and on collection, all that should be done. In that case, we can also select what? Some other, which means what? Informatica has got the provision to perform, to make use of the partitioning technique at specific level also. Specific in the sense, specific to task level, specific to transformation level. That's what I meant. For example, if you go to sorted transformation, which we have discussed, right? In that case, we need to go with what? Let's say hash key or module based. Or if you go to aggregator, same thing. Or if you go with, let us say, some other transformation, let's say expression, we don't care about this particular key based. Instead, we just care about, let's say, round robin. Likewise, depending upon the type of transformation that we use, irrespective of the logic that we get it from requirement. So our goal is what? Faster processing. So based on how this particular transformation is going to work, we need to select what? Appropriate what do you call algorithm, which is partitioning algorithm. That's what I meant. Yeah. That same means what? Everywhere, if it is let's say same partitioning technique, if you use, let us say, same will be used. Let us say first is what? Round robin. Yeah? A round robin will be used everywhere same, no change at all. T2 also round robin, T3 also round robin. So in that case, we don't need to what you call repartition the data which is already partitioned with some partitioning. For example, if you keep on changing, right? Here is one partitioning, here is one partitioning, here is another partition, right? So we are performing lot of what divisioning and subdivisioning, which will hamper performance. So this is always better to use this in case if you know like what you are doing, but if it is really required from the functionality perspective with respect to what or to meet the business requirement, then only we can think of using what other types of what we call partitioning techniques. Yeah, this is a simple way to understand like how this particular what I call different types of partitioning techniques are going to work. Fine. Any questions from anybody so that we can discuss about these questions? Then we'll talk about the rest of the topics. Yeah. Any questions from Dilly, Dinesh, Priyanka, and Subha? No. This is a very very important topic because uh, the reason why I'm saying is this is where your experience is going to play a very key role. Remember, yeah. So this configuration of this mapping or drag and drop, right? Anybody can do it, but what I call understanding this minute level of this what I call parallelism or any other optimization, which I'm going to talk tomorrow, which requires a lot of thinking before we apply to this particular application, which is very complex. Yeah. So that configuration part, anybody can do it. Yeah. So fine. So please start asking questions so that I can answer any kind of question at any time. Yeah. So functional, technical, or even from syntax perspective, any kind of question you can ask, I'll answer definitely. Yeah. So any questions from anybody? Yeah. If there are no questions, then we'll just switch to some practical part, then we'll continue this theory part, because continuous theory is not a good thing because we need to make it productive, right? This training. Yeah. So let us get into the tool for some time. Yeah. I'm just sharing my. Oh, it was not shared so far. It was shared only, right? Dilip, Dinesh,
Yes,
Priyanka.
it
It was
was
shared only. Sorry.
it was
Yeah. Let us get into the tool. Yeah. Yeah. So let us get into the tool where we'll move on to but another transformation. Yeah. So which one will pick it up? Simple or complex? Yeah. Let's go with the simple one because late evening. Yeah. Fine. Now, which transformation we have? What pending ones we'll see. Yeah. So we have got what update strategy. Yeah. So let us go with what update strategy. Yeah. So update strategy is a very good transformation. So how it works, let me talk about it. Then we'll get into practical example. Yeah. See, in Informatica or any other warehousing tool, right? So there's a concept called SCD, which is slowly changing dimension. Yeah. So where? So slowly changing dimension. Dimension, I think we talked about, right? What is a dimension? What is a fact? I think I talked about first day. Yeah. So which means what? Let us say today we get data like this 1, 2, 3 for one customer, and tomorrow we got data let's say 1, 2, 2, 3. So which means what? There is a change happened to only for second column. Yes or no? This is what called change, slowly change of dimension. Which dimension? Customer. That's it. It's a very simple way to understand slowly changing dimension. Dimension is what? Customer. Change is what? Column 2. Slowly second row. That's it. Now how to take care of this particular SCD? Yeah. So this dimension part. So for that we have got multiple types. Type 1, which is SCD type 1 we call. So type 1 and type 2, type 3. Yeah. So type 2 and type 3. Right. Right. The type 1 is a simple word we can use here. Override. Override. Yeah. Or overwrite, whatever you call. So and second is what type 2 history. So this is also history at what column level. That's it. This is a simple way to understand how this particular what these types are going to work. It's very simple, right? So that's it. Now let us understand details. Yeah, what is override? In this case, let us take same data here. This is, let's say, run 1.
Please enroll our general membership for $3.99 plan to get access of all the parts.
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $3.99 plan and grow your skills immensely. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.